So particle motion sign analysis, our second day of covering particle motion, we're going to allow ourselves to be able to use the graphing calculator. So I'm going to show you a trick in today's work that I hope kind of bridges the gap. And so I am going to focus my lessons in teaching you the tricks to sign analysis analytically, so in other words, without a calculator. But I do want you to, and I am allowing you to use the graphing calculator to make these problems much easier than they would be without. If you can do it without a calculator, of course, that's going to be the most important part, and you'll be better off long term if you don't use a graphing calculator for today's problems. Okay, so I am going to kind of just trickle it in because, like, again, I'm not too sure about the exam. We are going to cover what we're going to do today is something that we're going to do for quite a while moving forward, especially, which is utilizing interval notations. So we got a lot on our plate in the sense of same concepts from yesterday. So we spent a lot of time just focusing on this idea behind position in motion and the idea of motion. And now, and as I mentioned in my post in the assignment, I want to remind you that S of t, which we can also refer to as x of t or y of t, is the position of a particle. We can call it an object. It can be, this particle could be a person moving left and right, and they're pacing back and forth. We might not, we're not really, we're only worried about how they're moving and located. You'll see a problem often. They're on a tightrope. You got a spider that's going up and down a wall. The position, the height, the left and right direction. S of t is the position. V of t, the velocity, S prime of t, which we can also call V of t, is the velocity. Now, in some problems, as I noted, you may directly be given this velocity. And in your homework, there are a couple of, I think one or two problems, I think one problem at the very end where I explicitly give you the velocity and therefore you don't have to. In this topic, most all of the focus will be on the velocity function. And that's going to be the main difference about this course versus like a normal physics type of course that you would have taken in ninth grade. We're always, and especially in the introduction first half of AP Calculus, we're interested about rate of change. And we've done a lot of buildup to get to this idea of rate of change. Calculus is built on Calculus 1, or Calculus AB as we're taking it, is built on two foundations. The idea behind rate of change and the idea behind accumulation of rate of change. So rates, slope, and its applications. And so we've been building that up to now, and then the later half of the course, when we kind of go backwards. Okay, let's talk about position given the velocity, so given the rate. But the idea I want to say is the rate, the derivative, velocity is going to be your main focus of this material. Okay. All right, so velocity and S double prime of t is called the acceleration. All right, A of t. Now, we can also call this V prime of t as well. Acceleration is the second derivative of position. or we can call it the derivative of velocity. Well, because that's what it is. And this is the acceleration. Now, we are going to study acceleration, so for right now, acceleration is the rate of change of velocity. So how is velocity changing? We will focus that on it a little bit, and combined with velocity can inform how speed is changing. But we're going to save this for another lecture. All right, we're not going to focus that on today's, actually tomorrow's lecture. I say another lecture, but it's tomorrow's lecture. So we're not going to talk about, we're not really going to talk about acceleration today. You can find it. I want you to know, and especially since there's that problem from last night, and I said I would put it on here, that the derivative of velocity, the rate of change of velocity, is acceleration. All right. Now I did, of course, use yesterday's notation. I used ds dt. Same thing, dv dt. When we use this prime, s prime, that also means ds dt. But as we saw in yesterday's Q&A kind of type of part, a lot of you still think they're like fractions. So we want to understand that they're derivatives. And so I want to go back and forth between the prime notation and the dt notation of what it means. Interval notation. Today we're going to be talking about intervals. Calculus uses interval notation to give answers for a variable over a continuous values. So when we talk about a number line, 1, 2, 0, 1, 2, 3, 4, 5, and you've done this in your prior courses, and we were talking about something like we did over here, and this is the values of, let's say, x, then what we would done, we would say x is greater than 1 but less than 3. Now that's not interval notation, that's inequalities notation, okay? So that's how you used to do it. In calculus, we write the same thing as x, and it's 1 parenthesis 3. Now it's important to note that this is stating an interval, not a point. It is not the value 1 comma 3. It is the values of x such that x is between 1 and 3. So this is how we utilize the information in calculus. Now, if I were to do another number line, 1, 2, let's just go 1 and 2, and it's a closed circle to an open circle, then we would say This is, this is 1 with a bracket and 2 with a parentheses. And so brackets means including. So this is the values of 1 to 2, including 1. So x, so the value could be 1 through 2, including 2. One of the tougher pieces of information is the idea behind infinity. So oftentimes we're going to get problems where it's going to be like 1, 2, 3, and it might be something like let's say a closed circle above 2, and it goes on and on and on. Now, you would traditionally say this is x greater than or equal to 2, but for our purposes, the way we write this is bracket, because it's or equal, it can equal 2 to infinity. All right, because the idea here is that if you keep going on here, this is 4, and so infinity is over here, and negative infinity over here. It keeps going on and on and on and on. So we say 2 to infinity in this case. This is just notation. Another one in terms of notation. 1, 2. Let's say we had an open circle here pointing to the left, a closed circle here pointing to the right. The way we write this in calculus to denote all of these values. So this is x less than 1, comma, x greater than or equal to 2. But in calculus, in intervals, notation, which is how we're going to have to do it, we write this as negative infinity to 1, not including 1, union, bracket, because we are including the value of 2, to infinity. And this right here is how your answers will look. So in most all of the problems, when we're talking about intervals answers, we have them like this. Now, in yesterday's homework, we were only asking about at a point. Okay, so some questions in calculus, we only are interested at x equals 2, what is happening? At x equals 5, what is happening? At x equals 2, is the particles moving forward or backward or at rest? So we were only interested at that one point. But today we're going to ask, today's questions are going to ask, when is a particle moving forward? The answer is an interval. Okay, the answer is an interval. And what I mean by that is that when a particle is moving forward, a particle just doesn't move forward at x equals 1, and that's it. It's moving forward. At x equals 2 or x equals 1.2, no, it's not moving forward anymore. It's at that. So when we talk about moving, you move over an interval. Oh yeah, for the first 2 seconds, she was moving forward. Okay, it's an interval. When is a particle moving backwards? Well, the answer is also an interval. All right, so same idea. Oh, they're moving forward for the first 2 seconds and then backward for the next 3 seconds. All right, it's over a period of time, not just at an instant. When is a particle at rest. In this case, my answer is a point at t equals blank, you know. So in my previous answers, there were intervals, but at these problems, they are at points. Now, there are problems where technically you could be at rest for longer, for over an interval, but that's not going to happen until we look at actual graphs, which we're not. So for all of our answers right now, a particle is at rest for only an instant. All right, and please go back up to your notes. Justify. You'll see me always saying this: justify or explain your reasoning. And the reasoning for behind this, for a particle moving forward, we just simply say because the velocity is greater than 0. Moving backwards because the velocity is less than 0. It's at rest because velocity is equal to 0. Most all of these problems require you, especially on the free response, to just explain that one little part. It'll say, find the interval, and sometimes it's really nice and even says find the interval, when the particle is moving forward. Okay, you find your answer. And it says, explain your reasoning. And all you got to say is because the velocity, you can write out in words, the velocity is positive, or you can simply say v of t is greater than 0, which means the velocity is positive. When velocity is positive, a particle is moving forward. A particle is moving forward because the velocity is greater than 0. It means the same thing. Now, a lot of these problems require you to justify and explain. And so as I will teach you, the main thing when they ask the question, or when we ask the question, sometimes it's best to explain the reasoning first. Oh, this is when velocity is greater than 0. Okay, and then you find when velocity is greater than 0, and that helps you for many reasons, because that helps you explain, determine what you need to use, especially early on in this course. I mean, like I said, everything we're doing today is focused on the velocity function. So everything we need velocity. Velocity, velocity, velocity. If you don't have velocity, you're given position. Okay, take the derivative, find velocity. Oh, I'm given the velocity. I don't have to find it because they've given it to me. And now I need to do that work. You'll also be asked the question, when does a particle change direction justify? Well, that happens. The answer on this one is once again going to be a point, or points. I want to put a little parentheses around those. Point, or points. It could happen at more than one time. But the reason, so in other words, it's x equals, or t, I want to say t equals some value. The justification here is because v of t changes sign. Now, in your homework, I didn't give you anyone to. Well, actually, don't even worry about it. I don't want to say what you will and won't see on your homework. But we have this value right here. We're going to use a basic piece of knowledge right now in terms of when we do our work. And basically this is something that it's called the intermediate value theorem, but I'm not going to really cover it yet, intermediate value theorem yet, because the premise comes up later. But I think you'll agree, or you should feel, a continuous function, which is what we're using. We're going to be using nothing but continuous functions. A continuous function can only change signs when the function equals 0. Does not mean will change. So here's the basic premise. If you want to figure out when a function is positive or negative, you first need to find out when it's 0. Because when you know a function is 0, then if the velocity, in this case the function is velocity, if the function velocity is 0, then you know to the left and to the right, the function will either be all positive or all negative to the left of it and to the right of it. So when we do our number lines, we're going to get some values. We're going to have like A and B, where the function is 0. And that means that in this case, I have 3 intervals. For all of this intervals, this has to be either positive or negative. So this has to be all positive. It can be all positive or all negative. Now, it could have been negative, negative, positive, positive, negative, positive. It could be any combinations of positive or negatives. But the key idea here is that between A and B, between the values of A and B, if this is the only places where the function is 0, then between the values of A and B, it has to be either all positive or all negative. After the value of B, it needs to be either all positive or all negative. Before the value of A, it needs to be either all positive or all negative. And of course, you're probably wondering, so how am I going to find that out? I'm going to show you very shortly. There's a lot of buildup on this. This is something that I spent for those people who were Norda and Ariana, who were with me in the summer. We spent a good week just talking about this function analysis. Now the good, and you're like, well, why are we just doing it one day or half of a lecture that's being introduced? We're going to keep introducing this over the period of time in terms of how we do it. And more importantly, as I'm going to show you, we're going to utilize technology. Determine if a function is positive or negative in an interval. Step 1. Determine when the function, instead of saying a function, determine if, we're going to go straight up with velocity. All right. Well, the function is velocity, but it really applies to any function. Determine when velocity equals 0. That's your first step. Okay, so you're going to first determine when velocity is 0. All right. You will see in my solutions me talking about things like leading coefficients, me talking about things like multiplicity. You'll see things like m equals and LC equals. I don't want to jump and introduce that to you in one lecture. All right, so as such, and because I want you to use technology and I want you to first introduce the idea of how to answer these questions, and I'll let this know to both the tutors, I want you just to utilize the method that we're about to do right now. All right, Ariana and Norda, if you want to take it, that step forward and do it using the function analysis of the graphs, feel free. You are much better experts because you've already covered it over, over that week when we were introducing it, and actually multiple weeks for it. Step 2. Create a number line indicating the values of t when v of t is equal to 0. So this might, for example, give you like t equals a and like t equals b. So we set velocity equal to 0, and we have to solve that. As you saw in maybe one of your problems last night, this might require something like a quadratic equation where we have to factor. Factoring something with quadratics is something by now it should be assumed that you know how to do. So we set velocity to 0, and then we solve it, and we get like these two values. The next thing we're going to do is we're going to create a number line of the velocity values. So this is t and then the velocity values. And you're going to indicate where velocity is 0, like this. Step 3. And this is where this step right here is where you're going to use technology. You can use function analysis. Function analysis is actually our next unit. So I'm actually going to use that a little bit more there. We're just going to use technology. All right. Use technology. We are going to evaluate a point within each interval, all right, and state the sign in the number line. This is called, we're taking this number line and we're creating what's called a sign chart. All right. So we have these values a and b for the values of t. We're interested in the values of velocity, which are 0 right there. So the numbers of t go on the number line, and the numbers above are the velocity values. So this particle, for example, is at rest at t equals a and t equals b, assuming that a and b are both positive. And what we're going to do is we're going to pick, in this case, we're going to pick a value right in here. We're going to pick a value right in there. We're going to pick a value that's over here. Okay, so I'm gonna find the velocity at, I don't want to use a notation that's going to be a little bit different. I'm just trying to, because I don't want to use C, because C is technically something that we use for something else. We'll just call it T1. We want to find the velocity at T2, and we want to find the velocity at T3. Now, of course, you could do this without technology. You can just plug it in. But the idea here is that you're going to find the value. You're going to plug in a value that lands in that interval into the velocity. You're plugging into the velocity. Now, in using a calculator, You can do this by hand, but I'm going to put in y1, I'm going to put the velocity function. This is the easiest way. You can evaluate this however you wish to, okay? If you wish to plug in the numbers using parentheses, like because you're using like Desmos, for example, you can, Desmos actually, there's a lot of different ways. You can do this using a table. You can use this using a graphing calculator. There's quite a lot of ways. And actually, I'm going to have you do this all using technology. So we're going to put the velocity function right here. And then you need to evaluate. And the easiest way to evaluate is utilizing a table. Is to utilize a table. And the best thing I'm going to show you is an example. You can use a table, or you can just do y1 of t1, for example. That's kind of like usually how I do it. I just like to find those individual points. So the whole idea here is, so once you've done that, you will then have like an answer. So let's say you get like v of t1 is equal to 6, v of t2 is equal to 8, and v of t3 is equal to negative 5. Let's say you got that. So what we would do in labeling our sign chart is we would say that this is positive, positive, and negative. We're not worried about the actual value of the velocity. We just care about the sign. So you're going to find the values of velocity over there. Now, you will see me do things like, you'll see me do things like this. You'll see me do a graph. You might see me do like, oh, the graph is going through here. It's coming down, and then it bounces off. And then I might say something like the leading coefficient is less than 0. For now, you can ignore that. The idea here is that if you look at the function, the value that has the biggest, that's the leading coefficient, will determine the right side of the interval. And I'm going to try to trickle this idea in for you. The right side of the interval, the furthest right interval, if the leading coefficient, which means the number in front of the term with the highest degree, if that was negative, that means the far right interval is going to be negative, which means the graph's going to point down, because we're going to be dealing with polynomials. The multiplicity here is like 2, and the multiplicity here is like 1. And what this means is that at B, there's going to be a sign change, because at B, it's going to look linear on that at that point, and at A, it's going to bounce. All right, and it's going to kind of look like a quadratic right around that value of A. You'll note that I'll put that on my solutions that I work tomorrow. And this is a way that you can go about doing it. And if you have the time and to be able to try to do it this way, and you do understand what I'm trying to get at, doing it a little bit early will be helpful. Once again, if they allow calculator on the entire exam, I don't want to spend a week covering this. Hopefully by the time we get back from break, we'll know exactly how the exam is going to look when you have to take it. And if I have to utilize this more and go deeper into this when we get into our next unit after break, I can do that. So I'm leaving ourselves a way out where we can still answer all the questions and have the valuable knowledge, because the focus here is really on the intervals. Let's do an example. And I'm just going to give you, oh, we'll do SD. So S of t equals 5t squared minus 6t plus 3. Okay. And it says t is greater than or equal to 0. Now this problem right here could have implications, okay? So the fact that t is greater than or equal to 0, kind of does apply. Um, I want you to also note here that because t is greater than 0, sometimes I'll do like this and say here's 0 because we only care about the values of 0 to the onward. So the idea is that our interval starts at 0, all right, when we're talking about motion. So you'll see me do that. Indicate interval starts at t equals 0 for t greater than or equal to 0. So you're like, wow, we've spent a lot of time just going over all this stuff. We haven't even done an example. Don't worry, the examples kind of just lend themselves once I've done all this work. So the question is, A, determine when the particle is at rest, justify. B, determine when particle changes direction. I guess it's not a question. Justify. C, determine when particle moving forward, justify. D, determine when particle moving backwards, justify. Let you have a little bit of time to write that down. I'll give you a minute. Now, these instructions I've given you are the same instructions that you have on your homework. All right. The hardest part of these problems should be in terms of finding the values of t and, of course, the evaluating the intervals. So, like I said, the first thing you want to do is determine when velocity is 0 in all these questions. So the first goal is always, when is velocity 0? These are all topics of the idea of motion. And as such, we always want to start off with, let me figure out when velocity is equal to 0, which is also the answer for A in terms of justification. A particle is at rest when velocity is equal to 0, but in all these problems, I first need to figure out when velocity is equal to 0 anyways. But also as such, I need to first find velocity, which is the derivative of position. Since I wasn't given velocity, I have to find it. So what's velocity? What's the velocity function? Nice and easy. First time, I know I've been talking so much because there's a lot of just concepts that here that we would spend a lot of time in pre-calculus with that I know you weren't able to go through. So what is the velocity? What is s prime of t? Somebody. Don't all jump at once. I would like to get through this example without having just to rush it at the very end.
Can you say the question again?
What is velocity? What is s prime of t? It says right there. What is s prime of t?
S prime t. Would it be 10t minus 6.
10t minus 6. It's as easy as it gets in calculus to find the velocity, the derivative. And I even explicitly told you s prime of t. All right, so that's, you know, either there's individuals that are not paying attention, or you're not, you know, if it worries me to see so much silence for so long on a question like, what is the derivative of 5t squared minus 6t? I mean, plus 3. 10t minus 6, there's my velocity, and we're going to set that equal to 0. That gives me t equals 6 over 10, which we'll call 3/5. Well, I'm just going to leave it as 6 over 10. I don't really care. But you know what? I'll clean it up here. T equals 3 over 5. And that's actually going to be our first answer. That's the only one. So to answer question A, I'm going to answer all the questions actually at the end. Next thing I do is I set up my number line with 3 over 5. Okay. So now I want to pick a point. So that's for the values of t, and that's when velocity is 0. And now I'm going to pick a value underneath, below here and afterwards. Please give me a value that's, what is a nice easy value that's less than 3/5.
1/5.
That's a very hard, tough value.
0.
0. 0 is a nice, easy number that's less than 3/5. And give me a number that's nice and easy above 3/5.
1.
1. So I want to find v of 0, and I want to find v of 1. Okay. Those are not primes, that's just indicating where it's located at. So I want to find v of 0 and v of 1. V of 0 and v of 1. Well, you can do this by hand. I'm going to show you, though, how to do this by hand, as well as how to use technology really quickly. But v of 0 is what? You can all should be all capable of finding v of 0.
This is negative 6.
It's just negative 6. 10 times 0 minus 6. So, negative. What's v of 1?
4.
4. And therefore positive. You can do this over here with your calculator, and you can say like y equals 10, and you can use x minus, oops, 10x minus 6. We can go down here and we can change this to a table. All right. How did I do that? You just simply state that you want to do a table. So I changed it to a table. So let me show that again. I did y equals 10x minus 6. Now you can also, a lot of you can see that here's what the graph looks like. It intersects right there. So what I could also do here is I can also just type that into my graphing calculator and see that the graph does this, and that tells me also negative positive if it's below the x-axis, negative above. Once I do that, if I want to do something that's a different and I want to do a table, I can just hit the key and just hit the table, and then I just plug in the values. I said plug in 0, and then I said plug in 1, and so I got the -6 and 4. I just evaluated it. So if you're having trouble evaluating by hand, you can just plug that in. But make sure you're plugging in the velocity function. All right. So the answer for A, when is the particle at rest? The answer is t equals 3/5. And the reasoning, velocity was equal to 0. B, where does the particle change direction? It also happens at 3/5 because this is when velocity changes sign. Changes from negative to positive. I don't care if it goes negative, positive, positive, negative, it changed sign. C, when is the particle moving forward? That's a parentheses, 3/5, comma, infinity, because v of t is greater than 0. And D, when is the particle moving backwards? So here's 0 right here. And I know it says technically 0 is right there. Sorry. So it's 0 is right there, but it's negative right there. So the answer here is 0 to 3/5, and this is because velocity is less than 0. Velocity is negative. Now, technically, it's a bracket, but I'm okay. When the answer is a bracket and you write a parentheses, you're going to be fine. There's no, we don't differentiate that really in calculus. Basically, what I'm showing here with the 0 part is that our function starts at 0. And therefore it's negative right there, and then changes, then it's 0, and then it's positive, and that gives us all the answers. That's what you're going to be doing in your practice and assignment today. It's 9:01. Could have taken a little bit more time if we got some quicker responses right when I was asking. But beyond that, it's 9:01. I'll see you tomorrow. Homework is a handout after all, but it's only 4 questions. Very similar to this. The final one gets a little bit trickier, but it's still not that bad.